Okay, so here's another question that relates to CAPM. I mean, the reason why I'm laughing right now is because this is probably the 12th video that I've been like, hey, here's another video relating to CAPM. But all jokes aside, there's quite a few questions that you could see relating to CAPM, and especially that you could see related to beta. Beta being probably the most, I guess, like the most broad category of questions you may see, because you may see portfolio beta questions, new portfolio beta questions, individual betas, blah, 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 blah. But in this video, we're going to look at how to solve for a very strange version of individual beta questions, in which we're going to literally lever this notion of the correlation coefficient as well as the covariance relationship with the general foundation of beta. You'll see what I mean in just a second. So like all things, like all questions we do here at Eastman Helps, it's extremely important that you're able, one, to identify which chapter we're dealing with, then what topic we're essentially seeking, right? So what's our mission here? And then just go through your formula sheet and pinpoint that formula. Because in like any intro to finance class, either for your grad studies, your undergrad, even your CFA level 1, it's always based on something that exists, like it's logical, and there's a formula for it. In this case, I'll show you exactly what those formulas are. So let's actually try to read the question first, and then I'll tell you, well, oh my God, what formula do we need to use? And if we had a formula sheet, how easy it is for us. So let us assume that the correlation, all right, between PepsiCo and the S&P 500, which is also known as the market index, is equal to 0.75. So that's already pretty interesting. So we know that the correlation between PepsiCo and the S&P 500 is equal to 0.75. So we could write this as being the correlation between P and M is equal to 0.75. Okay, that's how I like to write it. It's kind of like my notation, but really just we'll roll with that. And we also know that the variance of Coca-Cola, okay, and the market index is essentially 0.5 and 0.28. So when you read this, they're telling you that, hey, the Coca-Cola's variance is equal to essentially 0.5, and the variance of the market index is equal to 0.28. The reason why I wrote that, and you saw it, even myself, I kind of got confused because I didn't do this question ever. So I'm kind of like, oh, where are we going with this? Is because on exams, they may actually really, for some reason, lever or use or try to put you at a disadvantage with worthy questions that are actually written poorly. So that's why I kind of just gave you exposure to a really poor show of grammar and syntax in a question. But what we want to figure out here is that the variance for Coca-Cola, okay, is going to be 0.5, and the variance, okay, for the market index is going to be 0.28. All right, and we're also telling you that the standard deviation, okay, of PepsiCo is equal to 5.28%. So you have a lot of information. So you could write this as being standard deviation is equal to 5.28%. You could also write this, if you want to be cute, as being 0.0528. Okay? And then you know me, I like to highlight our good old mission. What is our mission here? In this case, it's to compute PepsiCo's beta. Okay, so to compute PepsiCo's beta. That's what we're solving for. So a few takeaways, that are pretty important here. We know we're solving for PepsiCo's beta, so we could put this as being beta P, not beta portfolio, but really beta P as being our unknown. That's what we're solving for. But if that's what we're solving for, do we care about the information that was provided vis-a-vis Coca-Cola? No, it doesn't matter to us. So we could go ahead and just write that off immediately. So Coca-Cola doesn't matter. This doesn't matter at all, okay? So we know that that information will not be useful. Let's cross it out. Let's get it out of here as soon as possible such that we don't get kind of lost with it, okay? So now we know that we're looking for PepsiCo's beta, but unfortunately, if you remember this, when we talk about beta, there's really 3 ways for us to find it, and I can write it at the top. There's really 3 main principal ways for us to go about it, like where we see this notion, we see it in our K is equal to RF. Oh, sorry about that. RF plus beta. Notice we find our beta finally, minus, I mean, not minus, but times the market risk premium. So we see it here. We also see it in our formula for the beta, for the portfolio beta, which is literally just this right here. But we also see it in a very simple formula. And that one, I'm gonna write it right here just for it to be a little bit more, concise and a little bit bigger, such that when you review the question, it's easier. So if you had your formula sheet open, I don't need to go through it, but if you had your formula sheet open, you would know exactly what formula we're talking about. And this is the following. So the beta of any given asset, okay, is very easy to write. It's simply going to be equal to the covariance, and I guess I'll put this a little bit higher, the covariance of a given asset to the market portfolio over the variance of the market portfolio. Okay, so what does I stand for? Just to make it clear, and I'll highlight this in yellow. I stands for literally anything that is an asset. So this could have been like, in this case, Pepsi, but this could also be, for example, Tesla. This could also be AMC, little reference if you won or lost that wave. So beta could be written like that. However, we could kind of like translate this in a different way still. We could make this a little bit easier for us, or just different, depending on the type of information we have in the question. And you could actually write it as being P, or the correlation coefficient of a given asset vis-a-vis the market index times the variance, or the, I guess, the whatchamacallit, the standard deviation, sorry, of that given asset over the, I don't know why I'm like getting a blank, but over the variance of the market. I don't know why I was getting a little bit lost there. I guess it's like the 10th video that I'm doing, so my brain is a little bit fried. But yeah, so you can write this information as being probably the most crucial stuff that you can use here. So I'm going to just erase some of these things just because they don't matter so much in the grand scheme of things. So we have two formulas, as you can see, right? And they both mean the same thing. They both equal beta, all right? So what we're going to do now is we're going to try to figure out whether we have any of these missing pieces, okay? If we, or at least we could like get close to that. Because by definition, by the way, if I really wanted to, and I guess I'll go, we have time, why not? I guess I could even write this as being slightly different still. I could have wrote this as being, you know what? We could write a formula for beta as being equal to the correlation coefficient of a given asset to the market over the standard deviation of a given asset squared, okay? Because this literally will mean this as well, okay? But I'll like write a note, so don't you worry. So we could do that a few times over. We would have here, okay? So we could write this in like a bunch of different ways, because what I'm highlighting on the screen here is that this like little monster, this thing that, when students see this, they want to run away. It's like a, in French, we would say, it's comme le bonhomme 7 heures, or like, oh, I gotta go to bed, like I gotta stop. But when you see this, this literally just means, I'll give you like a good example. Let's say that you have 2 squared, right? You have the square root of 2 squared. It's like saying you have the square root of 4. It's like saying you had 2, okay? So there's a bunch of different ways of like drawing this up. It's just like a little example. Maybe it's like not a good proof, maybe it's a good proof. But the idea is that you could write this in a bunch of different ways, okay? And now, if we look at our prompt, that was just me giving you a quick crash course on how we could kind of portray the beta of an individual asset. But now that we have all of this, we could actually make this easier for us. We've like highlighted so much information in the question. We could plug it in within this formula and just use the one that works best for us, okay? So let's look at the correlation coefficient between PepsiCo and the market. We know that we have that right here. We know that we have that right here. So that's awesome stuff. You know what? I think I'm gonna go ahead. I'm debating if I want to copy this twice. No, I'm good, whatever. Yeah, so we know we have it right here. We know we have it right here. So that's awesome stuff. We also know that the return on the market is equal to that the variance on the market is equal to 0.28. So technically we could write this right here, right? We know that that's equal to this amount right there. And we also know that the standard deviation, alrighty, of the PepsiCo is equal to 0.28. So that's pretty interesting. I mean, I don't know. I'm so sorry if I'm getting lost. This is like the 10th video, my bad. But we know the standard deviation of PepsiCo is equal to 5.28%. So it's equal to this number right here. Okay, so we could simply write it as being what we have right here, what's being highlighted. All right. So if we were to plug this in, if we were to stop being weird and talking about proofs and blah, 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 if we were to plug this in, we would get something like this. We would get that the beta of our PepsiCo, okay, would look something a little bit comme cela. So we would have, I'm just going to try to zoom in a little bit, but also kind of keep track of all of our numbers. So we know that our correlation coefficient is equal to 0.75, if I'm not mistaken. We know that the standard deviation on PepsiCo is equal to 0.528. So we can maybe even extend the line here. And we also know that essentially the standard deviation of the market portfolio will be equal to the variance squared, okay? Because this is the variance, and obviously this is not the same thing as this. So we're going to need to do the following. So we're going to do 0.28 we're going to do this like that. That's going to be my little attempt to write it down. So we're going to say, after we compute this, that the beta of our portfolio is going to be equal to the following. Now, once again, at this point, if you've seen my videos, you know that I try to build my own questions that are a little bit more complicated and wordy. So hopefully you'll stand by me real quick as I solve this. So we're going to have 0.75, which is the correlation coefficient between PepsiCo and the market. They gave us that number. It's 0.75 times 0.0528. Why? Because that's essentially the sigma, the standard deviation of PepsiCo's returns. Okay? And then in our denominator, we're going to have the square root of 0.28. Why do we have the square root of 0.28? Well, it's because we don't want the variance. We want the standard deviation. And the variance squared, I mean, not variance squared, but the variance, like the square root of a variance, will give you the actual standard deviation. So we can do that. It's going to give us a nice little amount. It's going to give us a small little amount. It's going to give us this, 0.0748. That's going to be the beta of our portfolio. Now, there may be small rounding errors. That's totally fine. Don't you worry about that. But this is just another way for us to go about it. So that's going to be the beta of our portfolio. And it's really as easy as that. This question doesn't get any more complicated. And that's all that you got to do. So what this question tried to do is tried to highlight the different field of views, or I guess different perspectives you could take on one beta. What are the different formulas that are related to beta? And then once we work through correlations, once we work through covariances, once we work through variance or standard deviations, we're actually able to create this like Frankenstein version of beta. And this may be something that you have on your exam. So knowing how to manipulate this formula, right, and just identifying these pieces of information within the question will be helpful. Okay, it's not the sexiest thing ever, it's not the cutest thing ever, but it's still an important skill to have. Okay, so hopefully this helped you out. If you want more resources, if you want more information, do not hesitate to go on ismahelps.com, Isma Helps YouTube channel, and just look the name on Google and you'll find a bunch of PDFs. So Listen, this is made to make your learning process something that's not as static, something that's comprehensive and flexible, that makes you feel empowered, and that shows you that you're capable and able to really score really, really well. Okay? So have a good one. Enjoy the studying process, and I'll see you in another video.